All right, people. Third session already. How time flies when you're having fun. So we thought the second session was sets, but the third session is actually sets. So we're going to start up with sets, everything that can come for multiple choice, everything that can come in sets. So let's go. And as I go through the questions, I will take some time to just answer some of the logic behind doing sets for multiple choice. Now, sets is a peculiar subject. It's a unique topic for CSEC maths in that it only comes, in paper 1. That's the multiple choice questions. It only comes in these multiple choice questions. So these are all the different styles that you could look out for in the exam. So let's go. Let me get the answers for number 1 and number 2 immediately. Here we have a set. There are 3 elements in the set, and they want to know the number of subsets. So it's like if you have this set, right? And this set it has A, B, and C in it. The different subsets that can come out of this, you could get A, you could get B, you could get C. You all with me? You could get AB, you could get BC, and you could get AC in it, or CA, CAAC, same thing. And then you could get the total ABC. So how many is that? That's 7. But you can also get a set that has nothing in it, an empty set, right? You can get an empty set. So there are 1, 2, 3, 4, 5, 6, 7, 8 sets you can get. That's tedious. Imagine if they gave you A, B, C, D. You need to go and work out all the possible combinations you can get. So there's a shortcut. You take the number of elements. So there are 4 elements in this case, and you put it to the power of 2. So now we know there are 16 possible subsets. So in this, we have 3 elements. So 2 to the power of 3 is 8. Remember that. Number 2, if P is an empty set, this is a symbol for an empty set, then the number of subsets of P is, so what's the answer for number 2? What is the answer for number 2? If you have an empty set, how many different subsets you can get from the empty set? Well, you might think an empty set has no subsets, but there's actually one subset. There's the empty set, which is a subset in itself. So the answer is B, not A. Strange, right? We're going through all the different quirks that can happen with a sets question for CXE. If P is a set with 1 in it, how many subsets can you get now? So if the video is blurry, you know what to do. You know the drill by now. If the video is blurry, you can just raise up the resolution on your end. It's happening on your end. You just raise up the quality of the video. Find the gearbox icon. So how many subsets if you have like 1 element in it? Well, you could have the 1 and you could have the none. So there's actually 2. This is actually 2 to the power of 1, which is 2. It still works. Amazing, right? So there are 2, and this kind of explains why 2 to the power of 0 is 1. 2 to the power of 0, there's still 1 group of nothing. Okay. If the universal set is this, P, Q, R, S, T, U, and H is Q, R, S, then everything outside of H, well, H is Q, R, and S. So all the elements outside of H will be P, T, U, outside. This symbol could mean outside, right? That symbol is complement. The big boy name for it is complement, but we could just call it outside of H, outside of that, not included in H. It's not a part of H. It would be PTU, which is C. So that was easy. So when you see the symbol complement, it means outside. It means outside. So Abigail, you're reading the comment that I pinned underneath this by Samantha. If the video is blurry, go to the settings and turn up the resolution on your end. Right? Yeah, so like outside, so live, outside, we outside. Relationship, outside. I was telling my class, not really today. Anyhow, which of the Venn diagrams, you know, is the region outside of P intersect Q? So it's outside of P, but in Q at the same time. So we're using this symbol here to mean and. A little brief introduction to some symbols. This symbol, it stands for intersection. And it really talks about this spot right here in the middle. It must be in both of them at the same time. So a word you could replace it by, pay attention, a word you could replace it by is and. And the upside down version of the symbol is union. And union stands for everybody. So it really shade, if I shade the union, I'll shade everything. And a word you could replace it by is or. All right, so back to this question. They want everything outside P and everything that is in Q. So it must be in Q and outside P at the same time. So this one is in Q, but look this part in P. So D is wrong. This has P. This is wrong. It can't have any P. It must be outside of P. So this C is the answer. C is the answer. Somebody said video too clear. How to make it blurry. So yeah, this is how you're doing it, Talia. This is C. So y'all understand that? Let's go on to number 6. What is the region shaded in the diagram below? So in this diagram, I'm seeing that they shaded everything up. Everything is shaded. Now you see what CSEC calling shaded, right? And they call shaded hatch. So when you're shading something, you could hatch too. So what is the region shaded here? Everything is shaded, but B, we have something for that outside of B. B complement. Well, see, they use a kind of apostrophe here. It should be a little straighter. It's be a little straighter. It's more like a dash. So if the universal set U is equal to the, this is a brand new question, number 7. What's number 7? What's number 7? If your internet drop and thing and you miss out little piece, don't worry. This here, you can watch it over a million times. If the universal set U represent whole numbers from 1 to 10, we're watching number 7, guys, inclusive. And we have even numbers, and then we have prime numbers. And I want you to get the number of even numbers that intersect prime numbers. Well, I could just answer this one time because we know there's only one even prime number, and that is 2. 2 is the only even prime. All the other prime numbers are odd. I'm not saying all odd numbers are prime because 9 is an odd number. It's not a prime number. But all the other prime numbers are odd. Well, the only even prime number is 2. And now this symbol, this means number of elements, right? So like if I have A and you see A looking like this, what is the answer? Number of elements in A. So number of elements in A is equal to 6. Got it? Nice. So let's skip number 6. No, I answered number 6, B prime. I just didn't circle it. Everything outside of B. I say B prime, B complement. Everything outside of B. So you circle B and the number of elements that are even and prime. Yeah. How many even prime numbers we have? Just 1. And this is the whole numbers from 1 to 10 inclusive. So, okay, let me draw it out. Even prime. So we have 2, 4, 6, 8, 10 inclusive. And the odd numbers, where is this? Prime numbers going here. 1 is not a prime number, so you relax outside. 3, 5 prime numbers, 7 is a prime number as well. 9 is not a prime number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? That's everybody there. So this is my boy here, and the number of them inside here is 1. They didn't ask what it is in it. They asked how many are there. So don't go and put 2 for 1. Okay, let's keep going. Part 8, sorry. Prime numbers, even numbers, odd numbers, which are the following as an empty set. So you have prime numbers set up. Wait, question bank in Tobago, big up. We have the prime numbers, we have the even numbers, we have the odd numbers. All these questions, they come from the question bank, which is just like a compilation of all the possible styles of questions. And it's $200. And you can order it Anybody look Javish put it here, so you can just link up there. So prime numbers, even numbers, odd numbers, which of the following is an empty set? Which one you think? Have you ever seen an odd number that is an even number at the same time? This is like asking if you ever see a man that is a woman at the same time. At the same time. All right, this is like asking like if you ever see black, that is what how to say this, boy? This is a very strange time we live in. This is like asking to see if you ever see a horse that is a cat at the same time, right? You understand what I'm saying? A horse that is a cat at the same time. So even numbers, odd numbers, there's no intersection there. They are what we call disjoint. Write that down, disjoint set. So if you are even number, you're even. If you are odd number, is an odd number. So that is an empty set. Prime numbers that are even, there's 2. So that's wrong. Prime numbers that are odd, every prime number is odd except 2. Outside of prime numbers that are odd, yes, like 9. 9 is outside of a prime number, but it's still odd. So B, right? Cool. Yeah, that's what I'm saying on YouTube now. I could get it cancelled. P and Q are 2 sets. The number of elements in P or Q is 16. The number of elements in P and Q is 6. And the number of elements in P is 9. And they want to find how much in Q. Stop. Watch this, Alia. Watch this. I'm about to teach you a big thing here. Everybody pay attention to this. These are the 2 best looking sets you ever seen in your life, right? These dots just represent elements, Alia. Them is the best looking elements you ever seen in your life as well. I want you all to tell me now. Watch this, everybody. This is A. This is B. How many elements are in A? This is something you need to be able to do sets for CXC multiple choice. How many elements are in A? If you're not seeing the board good, you know what you need to do. You need to raise up the setting on your side. You need to raise up the setting on your side, people. How many elements in A? Let's take a little while before the comments reach back to me. The number of elements in A, I'm guessing that you all would have said it by now, is 1, 2, 3, 4, 5, 6, 7, 8, 8. Beautiful, I've seen it pop up. So the number of elements in B would be what? 1, 2, 3, 4. But how many elements in A or B? How many elements in A or B? Come true. How many elements in A or B? So a lot of people saying 2. 2 is not the answer. You all close off the chat. If you see, close off the chat and press like 1 time. That's always pay all your feeds for this class. So close off the chat, press like, and then open back up the chat. So you could type your answer. And if you type in 2, untype that. It's not 2. This is or. This one means union. This one means or. It means union, right? So it means you could be in A, you could be in B, you could be in A and B. Anything could work. So it means you want to include all. Remember, this union means shade everything. How many elements are there in everything? There are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Learn that this coming up in the next month is 29 days till maths exam. How many elements in A and B? Now, this one is the intersect sign. So now this is where you tell me 2. Now, something just play off here that I want you all to be keen, pay keen attention to. Something just played off here. Because if I add this and this, how much I get in? 12. So if I try to add up A and B, I get 12. But now when I add it up all together, I really get in 10. So why is that happening? Why is that happening, class? Why is that happening? It's happening because if I try to add A and B, watch this. I will add the 8 here, then I'll add the 4 here. I'll end up adding this one twice. So in other words, your pause is supposed to be raising now because this is the sweetest sauce that you're getting right now in terms of set. I counted twice. So the number of elements in A or B is actually equal to the number of elements in A plus the number of elements in B, but I need to subtract the middle portion here, the intersection, because I end up counting it twice. You see this is the sets formula. This actually comes at the start of the paper. This is a formula. This is in the formula book. To have a maths formula book, you could get that as well. Same number. It has all the formulas for CSEC maths. This is a vital formula. This formula, they could ask you this formula directly, and that is what this question is doing. This question is asking you the formula directly. A part is missing, but they give you all the other missing parts. Now you understand how to do this? All you need to do is write out the formula. I'm going to put it in red. So the number of elements, watch this. Pay attention, guys. The number of elements in P or Q is equal to the number of elements in P plus the number of elements in Q minus the number of elements in P and Q. That's good. So I just put in 16 is equal to P is 9 plus Q. That's what I'm trying to find. So let's call that X minus intersection is 6. 9 minus 6 is 3 plus X is equal to 16. Bring across the positive, 3 turns negative. 16 minus 3 is equal to X. So X is equal to 13. C is the answer for this question. Y is in the chat. Y mean yes. Y for yes, if you all understand that. Everybody understand? We have some SES students lining in the mix. SES students, don't get frightened. This sets, they introduce that a little bit in Form 1, and you'll reach like this level in Form 3. Form 3, Form 4. All right, guys. The question number 10, what y'all thinking? So the Venn diagram below indicates the number of students in each set. So you have universal set, that's students in the class. P is physics, G is geography. Nice. How many students do not study geography? How many students do not study geography? Hi, hey, Leslie, and what's up? Everybody understood the first one, right? This one, I just scroll up here because somebody shouted, no. Did I do a mistake? 9 minus 6, 3, 13 plus 9 minus 6. No, this is correct. Yeah. All right, so how many students do not study geography? Everybody understand. How many students do not study geography? Well, look. Just take out that 6. Wait. Do not study geography, so I include the 3 as well. So just 11 and 4, 15. Easy man thing. I find that was easy. How was that? How many students are there in the class altogether? Well, more easy thing. If they give it these kind of sets, I don't want to hear nobody in this live getting anything wrong. If they give it this type of sets, just get everything right. 4, 6, 3, 11, 10, and 11 is 21, and 3. Just now, it coming. 24, yeah, 24. So 24. Hey, it more. If Q, no, this is a brand new question. So 10 and 11. Q. So what they'll do in CXC, they'll say like question, this and that refers to that. And sometimes they even draw a line like here to show you that this is a new style, new question. So what about this question here? If Q is equal to A, B, C, D, E, how many subsets can be obtained from the set Q? How many subsets? We do this already. This came already. This is just what that 1, 2, 3, 4, 5 elements. 5 members. We either call them elements or members. So what I tell you all to do, what I told you all to do, 2 to the power of, so we're not doing any long sessions yet. The long sessions will come after April, where we'll be doing a bunch of paper 2s and things. That's on the run up to the exam in 11 days. So it's just 2 to the power of number of elements. 2 to the power of 5 is 32. Okay, so that's D. Right. Good. What number goes in P intersect E? So you want to know what to put here. numbers from 1 to 10 inclusive. You have your prime numbers and you have your even numbers. So the CXC will find some way to ask you to see if you know that 2 is a prime number. So one number goes in here, the number 2 actually goes in here. This is a prime number and it's even. Other prime numbers will be like 3, 5, not 1. 1 is not a prime number. 1 is what? The identity, multiplicative identity. 1 is not allowed. So 2, 3, 5, 7, not 9. And even numbers will be like 2, 4, 6, 8, 10 inclusive, and then you could put 1 on the outside here, and you could put 9 on the outside here. So one number goes in P and intersect P. They didn't ask how many go in, right? This time they asked what is the number that's going in there, and the number is that. What is the value of the number of elements outside of P? Outside of P, how many elements do we have? Now, it's very easy to see because I write up everything for you. But a lot of people is stop at 4 and forget you need to count these 2 as well. 1, 2, 3, 4, 5, 6. Hey, look, sleep, boss, you on, boy. You on from a physics class earlier. You on from a physics class. And at time, the man sleep or any class and the brother come and troll him and talk to me and thing. Man sleeping and the brother talking to me. So anyhow, 1, 2, 3, 4, 5, 6. But Johannes do good. Johannes stop the class and things sometimes. So 6C, what is the value of everything outside of? Nice, you're all doing good. What is the value of every? Let me see if you can do this one by yourself. Let me get rid of all these things that I write up here. 4, 6, 10, 9. Right? And I'm going to snap it. And I want to see if you all can do number 15 for yourself. Ooh, they didn't need to come out that big, bro. So I'm going to zoom in on number 15. Try this one for yourself. I still had to post a picture from my physics class, boy. Why shall I do number 15? I need to ask this question. Anybody here just drink room temperature, pour out of the container, no sugar added, no nothing, milk, just so? Like, you just drink that just so? I find people who drink that just so, that weird, boy. Milk just so? That's very weird. I need to post that on Instagram. I have a big problem with that. Until they don't drink that, well done. Nobody's do that. Nobody's do that. People who doing that, I'll have it rough for CXC, boy. What is the value of everything P and E? So it must be in P and E at the same time. 1, 2, 3, 4, 5, 6, 7. C. So if you get C, you're good to go. I mean, if you're putting cereal in your milk, cool. If you're making porridge, cool. If you're making tea, cool. If you're adding something, cool. But just milk, room temperature, just so, that is wildness. Which of the following sets is defined by, watch this. Lots of people have problems with this style of sets. Watch this. Are you a person who gets confused when you see this? You get confused when you see this? Let me be coded for you. Remember, Z means integer. You all know all these symbols? Let me take you through the symbols. Let me just take you through the symbols real quick. Wait for me. That's natural numbers, right? What is natural numbers? That's the set of numbers, 1, 2, 3, and so on. Whole numbers is W. What is whole numbers? Whole numbers is the same thing. It's the same thing, 1, 2, 3, and so on. But you could throw in 0 too. 0 get blind. What's the next one? The next one is the integers. Integers is the same thing. So 0, 1, 2, 3, and so on. But with integers, you're allowed to go backwards. I'll again refreshers here. Now, if you go backwards, you're going to the negative land, right? And if you're going into negative land, what I mean? You're going in the reverse kind of backwards, right? So negative 3 and so on. And again, refreshers. Now the symbol for that is Z. What else? What comes next? What comes next, right? Rational numbers. Rational numbers is like Q. Rational. So rational numbers these could be expressed in the form P over Q, P over Q, where, so rational numbers belong to the set where P and Q, you can just get accustomed to it, belong to the set of integers. So rational numbers just makes allocation for fractions. Somebody keeps saying question 4 missing. Did I leave out question 4? Oh, how I leaving out 4 here? And so on means just keep counting 3, 4, right? Then you have, we nearly done. You have irrational numbers. So I'll use I. Some people use Q complement, which isn't altogether correct. But irrational numbers, irrational, how do you spell that? I'll go and figure out how to spell irrational. Irrational numbers. So irrational numbers, we don't really have a thing for it. Irrational numbers cannot be expressed like this, right? So that's what we see. Cannot be expressed like that. They cannot be rationalized as a fraction, as a single fraction. They are still members of the real number system. But they cannot be expressed like this. What we need to know is examples. So pi is an example of an irrational number. Not 22 over 7. 22 over 7 is rational. Look, literally saying 22 over 7. 22 over 7 is just an approximation we use for pi. I remember talking to some maths teachers, and the maths teacher themselves fighting me down. Pi is 22 over 7. That's just an approximation. 3.14 is also an approximation for pi. The truth is, no one knows exactly what pi is. It's impossible to know exactly what pi is. God must know what pi is, but it's impossible to know exactly what pi is because the numbers just keep changing. As you go further down, the numbers just keep changing in an irrational format. You can never tell there's nothing recurring going on here. So it's what we call an irrational number. Another example is the number E, right? Euler's number, it's called, or what's it? Square root, SID, square root of 2, square root of 3. These are irrational. Square root of 4 is not irrational. Square root of 4 is 2. But if you can't find the exact square root, it's irrational. These numbers don't produce rational fractions that you can make. So all of these guys, watch it, people. Oh, this is important. This is important. You must know this to be able to make it in the multiple choice. Something on this could come. Like one little trick on this could come. It can even come in paper too. So all of these belong to the big boy set called real numbers. So real numbers are numbers. It include rational and irrational numbers. Because if you really study it, you have natural numbers, you have whole numbers, you have integers, then you have rational. So you have natural, whole, integers, rational, then you have the irrationals lying on the outside, and then you have the whole real number system. That's everything in a nutshell. Now somebody mentioned complex on the outside here. Complex number system, and thank the Lord, we don't need to deal with that yet. So the complex number system deals with imaginary numbers that come from this guy, square root of -1. If you put this in your calculator, now your calculator will say, nah, boy. Nah, bro. That's what your calculator can say. I won't say that. I say error, but we don't need to deal with this. Don't worry about that. So for CXC, not even hard maths, you need this. For pure maths, you're going to have lots of fun with this in Unit 2. Javish. Right. Javish. Aren't you doing that right now? Right. So, but for now, you're good to go with this. All right. So let's go back to what we're doing here. Which of the following sets is defined by X belongs to the set of integers and it spans from -3 to 3. But watch this symbol and watch this symbol carefully. This means don't bother to include this because it's not equal. It's just more than this. So I need to start actually at -2, -1, 0, 1, 2, and stop on 3. Include that. So I'm looking for this. Where is this? Here. The answer is actually C, not D, because they say don't include. If they wanted me to include it, I put this. So don't include it. Are they learning the tricks? Are they learning the tricks for sets? Right, go and tell all your friends. We just have 3 more questions, 3 more different style of questions that come for sets. In a class of 23 students, 11 students physics, 17 students study geography. What is the least number of students that study both physics and geography. So we have physics, geography, in a class of 23 students, 11 studying. Why go through all of this? What I could use for this, Alia? What I could use for this? I could use the formula. I could also use common sense, 11 plus 17 minus 23. But remember the formula. Let's call this NP. Let's call this number of students doing geography. So what is NP or G? 23, right? So and then I do the number of students doing what? Physics plus number in geo minus the number in physics and geo. So the least number of students that study both are trying to figure out this guy here. Now this formula could be right interchangeably. I could put this here and this there. That's algebra. But let me do it this way. So I have 23 is equal, and let's substitute now. Minus, and let's call this x. This is what I'm trying to find. 17 plus 11 plus 17 is how much? 28. So I'm going to get 23 is equal to 28 minus x. It's clear to see now that x must be 5. Or I could just say 23 minus 28 is equal to negative x. Negative 5 is equal to negative x, so x is equal to 5. Just finish it off. Are you good? Number 18, we're down to the last 3 questions, and we're going to close this set session. Which of the following is true about the above information? M is this, N is this, P is that. So what is true? Oh, geez, you need to read everything now. What is true? Which of the following is true about the above information? Richard, somebody's behind you, Richard. Richard, is someone behind you? Which of the following is true about? I'll talk to Richard. There's somebody behind Richard. Which of the following is true about the above information? M, this symbol means belongs to, like is a subset of. So I could find everything in M and N. Is that true? Is M a subset of N? No, it's the other way around. It's the other way around. So let me check again. M and N is 0. So meaning belonging to M and belonging to N at the same time is 0. There's nothing. So let's see if there's any intersection between M and N. No, there's an intersection. There's A, B, C, and there's N. In fact, this is a subset of this, so there's a big intersection. And N actually living inside M, B, C, A. Think of it. So this is wrong. That's not true. What, boy? Which one it is? Which one it is? So this is not true. This is not true. M intersect N is M. If I take M and I find whatever intersects with N, I'll get back M? No. Because M intersect N, BC is this part here. And BC is actually N. So this is the true one. Y'all understand that? So M intersect N is N. Nice. Sweet. So this is a question that comes pretty often as well. Something like this comes to CSEC. Watch out for it. Watch out for it. Be ready for them. M intersect N intersect P. M intersect N intersect P. Wait. I want something that is in M, that is in N, and that is in P at the same time. That's what it's saying? Yeah, boy. It's in M, N, and P at the same. There's nothing. Nobody doing that. Nobody holding down that role. So that's an empty set. An empty set. Cool. Last question. Which of the following would form disjoint set? So once again, they're giving you back this even prime number. So make sure you know. Make sure you know. You need to know this for multiple choice. Make sure you know what's an even number. Everybody know that. What's an odd number? What's a prime number? Also, what's a composite number? What is a square number? All these types of numbers you need to have down your belt. And you also need to know the difference between factors and multiples. So like if I ask you for the factors of 12, you would give me 1, 2, 3, 4, 6, 12. If I ask you for the multiples of 12, it'll be 12, 24, 36, and so on. Make sure you know those things because they ask you about it inside of a question. So which of these will form a disjoint set? Once again, there are no even numbers that are odd numbers. This is the popular one that they will do. No even numbers that are odd numbers, right? Prime numbers and rational numbers. Prime numbers and rational numbers. All prime numbers are rational numbers. All prime numbers is just a number, right? Irrational numbers and real numbers. All irrational numbers are real numbers. Anyway, they still belong to the real number system. Multiples of 3 and factors of 27. Multiples of 3 would go from 3, 6, 9, and so on. Factors of 27 start with 3. Well, start with 1 and then 3. So there is an intersection there. There is an intersection there. Oh, there's also 9. All right, people. All right, people. So that brings us to the end of sets. I hope everybody ready for sets. If you're ready for sets, let me hear some readies. Or if you feel like you're ready for sets, multiple choice. Sets is a unique topic that only comes in the multiple choice. This, what you're watching here, is the crash course for the Student Hub. Remember, the Student Hub is, well, the Student Hub has 2 parts. There's a free part, which has something like 22,000 students. How much it have, Javish? About 22,000 students from around the Caribbean inside a Discord server. If you're not in there, get in there. It's like heaven. Get inside there now for exams and get all your past papers, everything that you need. Trust me. All the resources that you're looking for whole day, get there. Why isn't it chat if you're in the Student Hub Discord server? If you don't know how to get in there, just go on the Student Hub Instagram. Search Instagram. Go up on the Instagram, go on the Student Hub, click the link in the bio, you're inside. That's the free side of the Student Hub. And then there's the premium side, where we have things like crash courses and whole lessons right around the year for all the CSEC subjects and things. Top teachers in Trinidad, and we do really well. We have students making the merit list every year. Good things. So look out for these crash courses. Here are the dates to sign up for them. You just need to WhatsApp this number, 472-4221. Speak to the admin. Let them know they'll show you the payment methods. We have students from all around the Caribbean, Jamaica, Antigua, Dominica, Guyana, Grenada, Barbados, you name it. Jump in the crash course. Crash courses are one of the best ways to get the spark to get going into exams. I think that is it. We're bringing down this 3rd session, Love and Blessings, people. On Friday, we'll come through with, what's the next topic? I think it's measurements. And that will be at 8 p.m. on Friday. So look out for that. We just getting the ball rolling. We'll be doing some longer sessions coming down near to the exam where we'll be looking at paper 2s. Love and blessings, people. Next session is Friday at 8 p.m. So anything you could just, as I said, the last thing I'll leave you on with, you can just follow me at Kerwin Springer and you'll see anything I have for you all, any news and CXC, anything, the announcement there on Instagram.